Good evening, students. I appreciate you finding time in your schedules to do your notes this evening. This is Wednesday night's notes for Thursday's class, and our topic for Thursday is rotations in the Cartesian coordinate plane. Okay, our objective, the student will learn to apply rotations to objects in the Cartesian coordinate plane. Again, these are the notes for Thursday. That will be October the 3rd. Copy your objective and your date. And as always, press pause anytime you feel like you need more time, and then hit play when you're ready to move on. Okay, same basic rules and guidelines that we've looked at for the past couple of days still apply today. First off, our name for our XY axis that we've been graphing for over the years is called the Cartesian coordinate plane. Any location in the CCP can be plotted with an ordered pair, x comma y, and we mentioned that the x and the y have names. They are the abscissa for the x and the ordinate for the y. And today we're going to be working specifically with rearranging the abscissa and the ordinate. Okay, so let's get started and have a look at that. And of course, still keep in mind that our original figures, our pre-images, have capital letters as their corner points that they're named after. But after we apply a transformation and end up with an image, now we use the prime indicators. A becomes A prime, B becomes B prime, and so on. And then as further transformations continue to be applied, then you get A double prime, B double prime, and so on. And they can do that as many times as they need. Okay, now rotations are going to be something out of the, well, let me put it like this, out of the isometric transformations, that is, the ones that do not change sizes. Rotations is easily the hardest to deal with because you cannot simply follow a set of rules. Okay, you have to think about what is happening in the graph, where you are leaving in the graph, and where you are going to in the graph. Okay, so a couple of rules, or a couple of guidelines is a better way to put it, that we have to follow is for a 90-degree rotation, which of course is 1/4 of a circle. 90-degree rotation, the abscissa and the ordinate are going to swap places. Okay, but we're going to have to watch for possible sign changes as we move in and out of various quadrants, and we'll talk more about that here in a second. And then we have the 180-degree rotation. Okay, for that, the abscissa and the ordinate are going to stay the same, but once again, we have to watch for possible sign changes as we move in and out of various quadrants. Now, you should be familiar with the quadrant naming system, okay? And if you're not familiar with it, you ought to be able to figure it out pretty easily. Okay, quadrant 1 is the quadrant that exists upwards and rightwards of the origin. Quadrant 1 is the one where everything is positive. We line up with positive x-axis and positive y-axis. So there's no such thing as a negative abscissa or negative ordinate in quadrant 1. From there, the naming system goes counterclockwise, that is, against the direction of the clock, and it goes to quadrant 2 and quadrant 3 and then quadrant 4 as it completes the circle. As you can see in quadrant 2, which is up and to the left of the origin, we line up with the negative x-axis in quadrant 2, but the positive y-axis. So a negative abscissa, positive ordinate. In quadrant 3, which is down and to the left of the origin, okay, everything is negative. We line up with the negative x-axis, the negative y-axis. So we have a negative abscissa, a negative ordinate. And then quadrant 4, down and to the right of the origin. Okay, that lines up with the positive x-axis, the negative y-axis. So that's going to give us a positive abscissa and a negative ordinate. If you have not learned that stuff yet, you probably need to spend a little bit of study time getting that memorized. You are expected to know the positioning of the quadrants, and of course, based upon which quadrant you're in, that should line you up with the positive or negative sides of the x and y axes. Okay, so let's take a look at this. Now, a lot of people may still think it is an easier thing to do to employ the little trick that I showed you for rotations in the CCP. Okay, which the trick was to pin down your point of rotation, like on a piece of paper, pin it to your desk, and then complete your rotation by spinning the paper, and that would give you a visual of what it is that you can expect from your answer. It's not a bad ploy when you're working in the Cartesian coordinate plane. However, it can be a little confusing with the graph paper because you're constantly going to have to be going back and forth and back and forth. Okay, so if you do attempt to do that, basically we can pin down the origin and we can rotate into any direction, any quadrant we want, a 90-degree rotation or a 180-degree rotation. And as you can see, my graph isn't perfectly lined up. Okay, but 270 degrees, 360 degrees will bring you all the way back. Now, you may have noticed that when we talked about the different types of rotations, that we mentioned a 90-degree and a 180-degree, but we did not go higher than that. I did not mention 270-degree rotation. Okay, because think about it. If you're talking about a 270-degree rotation, that would be 3/4 of a turn going around a circle. Okay, well, instead of going 270 degrees one direction, wouldn't it be the same thing just to go 90 degrees in the opposite direction? And that's pretty much the truth of it. So that's how come you don't see measurements like 270 or 360 or anything really bigger than 180, because anything bigger than 180 is simply a rotation in the opposite direction. Okay, so you could choose to do the rotations, but I'm going to show you how to follow this along with the rules that we just talked about. Okay, so basically what we're going to do is we're going to follow those two instructions we have over there. We're going to rotate triangle ABC 90 degrees counterclockwise around the origin to get A prime, B prime, C prime. Then we're going to rotate triangle ABC 180 degrees clockwise around the origin to get A double prime, B double prime, C double prime. Okay, so let's start off with the red one here. We're going to rotate ABC 90 degrees counterclockwise around the origin. Okay, now let's look at triangle ABC for a second. Where is triangle ABC? Which quadrant is it in? ABC lives in quadrant 2. And as we know about quadrant 2 is on the negative x-axis, the positive y-axis. That's how come all of these coordinates, A, B, and C, have negative abscisses and positive ordinates. Okay. Now, if we rotate 90 degrees counterclockwise, where will that send us? Okay, well, 90 degrees is a quarter turn, and clockwise is this direction. So that's going to bring our triangle into quadrant 3. Okay, well, what are the properties in quadrant 3? Obviously, we cannot use these values that we have for these ordered pairs because in quadrant 3, the signs are not the same. Okay, in quadrant 3, everything is negative, negative abscisses, negative ordinates, but the rule says we can still use these values if we learn how to use them. For a 90-degree rotation, the rule said we're going to switch the position of the abscissa and the ordinate, but we have to apply the signs for the coordinates or the quadrant that we are going into. Okay, so point A is going to rotate to point A prime. Okay, as point A goes to A prime, the abscissa and the ordinate switch. So instead of being -6, or instead of just being a 6 and a 2, it will be a 2 first and then a 6. But what will the signs be in the third quadrant? In the third quadrant, all signs are negative. So our point for A prime is -2, -6. Again, the abscissa and the ordinate switch, and we apply the signs for the quadrant that we are in. Quadrant 3 has both negative. How about B to B prime? Well, the value for B has a 4 for an abscissa and a 5 for an ordinate. We're going to switch those for 5, 4. Okay, and going into quadrant 3, we will be both negative. So B prime will be located at -5, -4. Okay, what will C become as it moves to C prime? The 1 and the 3 will switch places, and in quadrant 3, everything is negative, so it should be a -3, -1. There are your 3 corner points for the polygon A prime, B prime, C prime. You can connect your dots, and you have rotated triangle ABC 90 degrees counterclockwise around the origin. How about our second goal over there, our second task? Rotate triangle ABC 180 degrees clockwise around the origin to get to A prime, B prime, C prime. Okay, well, one little side note question here for you. Does it matter if you rotate triangle ABC 180 degrees clockwise or 180 degrees counterclockwise? What happens if you go the wrong direction on this? Well, if you go the wrong direction on this rotation, it won't matter because 180 degrees one direction around a circle and 180 degrees the other direction around the circle is still getting you halfway around a circle. So it really doesn't matter which direction you go. But on triangle A prime, B prime, C prime, could you have gotten it wrong if you went the wrong direction 90 degrees? Absolutely. Okay, a wrong turn on the 90 degrees would have put triangle ABC in quadrant 1 rather than quadrant 3. That would have messed up all of our signs. So we definitely got to pay attention to which direction we are going if we're taking a smaller than half of the circle rotation. Anyway, let's have a look. We're going to go from ABC to A prime, A double prime, B double prime, C double prime. Now the rule said that if you're going to make a half circle rotation, 180 degrees, that the abscissa and the ordinate get to stay the same, their values anyway. Okay, but we have to determine what quadrant we are going into so that we can get the correct signs. Well, 180 degree rotation around the origin is going to take us out of quadrant 2 and put us into which quadrant? Quadrant 4 is where A double prime, B double prime, C double prime is going to end up at. So what are the properties in quadrant 4? Okay, what's going to be positive, what's going to be negative? Quadrant 4 lines up with the positive x-axis, the negative y-axis. So we'll end up with all positive abscissas and all negative ordinates. So let's have a look. A is going to go to A double prime. That's a 6 and a 2 for the abscissa and the ordinate. The rule said we get to keep the abscissa and the ordinate the same, still a 6, still a 2, but we have to apply the sign rules for quadrant 4. That would be a positive abscissa, positive 6, and a negative ordinate, negative 2. So A double prime is at positive 6, comma, negative 2. Where is B going to end up at when it goes to B double prime? B is at 4 and 5. We're still going to have the 4 and the 5, but what are the signs going to look like? Positive 4, negative 5, because we are moving into quadrant 4. How about C to C double prime? Still going to be a 1, still going to be a 3, but it'll be a positive 1 and a negative 3. You have all of your corner points rotated. You can connect the dots, and you are through. You can see that this is very simple. I mean, it's not a difficult concept. It's not a difficult skill, but it does involve some facts that we are going to have to memorize in order to be successful at this. Well, that's all the notes. Bring your notes with you to class tomorrow, and we will run through the activity and see if we can figure out how to rotate some of our polygons off the wall and get them into different quadrants. I apologize for the notes being a little late getting posted today, but I do appreciate you tuning in, and I'll see you in class tomorrow.